Good afternoon, everybody. A very warm welcome to one and all for this web interaction on the topic of nuclear science and technology. I am Prashant Rawat from the Department of Nuclear Science and Technology at the University of Petroleum and Energy Studies, Dehradun. Any general discussion still in the present day world on the issue of nuclear science and technology revolves or is put into perspective by the energy needs, the energy consumption of the country and the world. For the uninitiated and for the beginners, for the students, it might look a bit strange and awkward that such a vast and varied field of interest for one and all is discussed primarily in this context only. So let us just see as we progress into the discussion, into the interaction, we will realize that it's not just the energy production, and consumption, etc., that is the nuclear energy, which actually should be playing an important role while discussing this topic. There are other issues also which should be. But let's start with what is primarily a very big factor, that is the energy consumption. Understandably, and everybody agrees to that, the world per capita energy consumption has been increasing. Initially, in the last century, it was quite progressing at a linear rate, but later on it has picked up and the consumption is rising steeply. In fact, the question is it so important that the energy production be looked day in and out for its concerns? As we understand, we require energy, the power for all our day-to-day activities. Whether we sit in our offices, we use the electricity for ACs or fans, for lights, whether we travel, whether we are at home, we commute, more and more of these places are using electricity to run our daily lives. In fact, energy or the electricity, as I may still reduce it, the all forms of energy too, is the most important commodity for humanity these days. So, a rise in production of the electricity or energy is supposed to make and is indeed making the lives of the people easier. Any loss in the production is creating hardships in the lives of the general people. So without energy, the production will stop, and as they say, the economies will dwindle and even crumble. So indeed, energy is still playing a very large part in our day-to-day lives, and we require this energy. So do we not have sufficient sources of energy at hand that we really should be bothered about it? Do we not have anything in a system in place so that we don't have to bother any further? Our predecessors, haven't they put into place a system that is we don't have to bother about the energy production? We have that thing and we bother only about how better to use this energy for our advancement, for our safety, for making our life much more easy. As is the any drop in energy is going to create problems for us, and the energy production is not so easy. In fact, in the present day world, the advancement of the society is being measured in terms of the energy consumption by the society. So in present day world, if we look at different countries as different societies, the development achieved by them, the countries as such, are measured by the units of electricity they consume. And if we were to take into consideration the advancement mankind is making with time, we really do see that the luxuries in life, the freedom man has been achieving over nature, has been increasing with the increase in generation and consumption of energy. So, as the slide you would be watching on the screen suggests, long back we were just hunter-gatherers, then more and more advancement, sophistication into mankind happened, and with that happened the increase in consumption of energy. So, one may say that the not only the growth of the technology is equal to power, and that power is these days presently being measured in terms of units of power or units of electricity. The more we advance, the advanced we become, the more energy would be consuming. So, just general look over the energy used by the different countries in the world, and if we were to look, the developed nations are the ones which consume most energy or more energy than the countries which are not supposed to be developed and underdeveloped as they are. So indeed, by now it's very clear even to the beginners, to the ones who are initiated presently into this field, that energy consumption does have a very direct role in the advancement of the society. The more advanced a society is, the more energy is being consumed, and hence there is this. So, if we were to look at the idea of advancement, that man continuously has to advance, has to progress, with this factor that it is bootstrapped, the energy consumption is bootstrapped to the advancement of the society, there is definitely a very much need or desire for more and more energy to be produced and its consumption. So, if we were to get into the quantification of this qualitative understanding, more or less the energy or the electricity that has been produced has tripled since 1970. The graph clearly shows how with each year the energy produced has been increasing. If this is this thing that we require more and more energy if we were to progress, then there is a need to look into what are the sources from which we get this energy. Still, the fossil fuels account for about 65% of the sources for this energy production. This is not only true for our country, but it's true for the entire world. So these fossil fuels, be it in terms of coal or gas or oil, they are still the biggest source for energy production. After that, we may have worldwide nuclear, which comes to about 17%. When we come to the Indian scenario, just in a moment, this reduces still further. The nuclear part goes still down by a factor of 4. Hydro about more or less 16%. So what is wrong if this is the distribution of sources for the energy that is being produced, for the energy that we require now, and for the energy that would be required in future? By now, it's very clear to everybody, and previously, maybe only those who were interested in seeing the impact the different sources that are used for energy production are making on our environment, on our daily lives, would have seen it. But by now, even for those who are not so directly involved with it, would recognize the harmful effects that some of the sources for our energy production are having on our environment and hence on our lives. It is now undisputably clear that fossil fuels are the biggest contributors to the damage that is happening to our environment, and that the environment in fact is getting damaged and is adversely beginning to affect our climate and our day-to-day lives. Even more than that, some of the experts, arguably at least we can say that, give attribute reasons for some of the cardiovascular disorders, some of the diseases, etc., to these sources for energy production. So there is also this fear that arises time and again that maybe these sources themselves do not have very long life, though that is now being each passing day as newer and newer quantities of these sources are being discovered. So even if we were not to fear for the longevity of these sources, there still is undeniably a very negative impact of these sources, fossil fuels, on our environment and on our lives. so much of pollution, so much of havoc that is being created by the pollution in some parts of the world, as we see in some of the days, mostly in winter. It's very clear indication that we really have to worry about these sources for our energy production. And as is clear, we do require energy. We cannot stay without energy. Even our present day lives would go into retro, fall down in quality, and if we were to progress, we require more and more energy. So there is this need for whatever energy sources that is playing a major chunk, a major role in the energy production sources, they have to be changed or replaced by some other sources. So what are the alternatives that are there for this? And as I move forward into the alternatives for the fossil fuels that are sources for our energy production, the power production, just a reminder to what the scientists are providing to us the data actually of global warming and the CO2 and the carbon imprint that is being, or the carbon loading that the sources for energy production are doing on our environment. As I mentioned, there is this fear also, but some people are now not so worried about this aspect of oil running out, or if not just the oil, other sources, fossil fuels, because newer sources for these are being discovered. Of course, they are not going to last for eternity, but still, for some time to come, we may not, as some people would like to reassure us, bother so much about their uh, existence. But it's true that while world over the total production may not be falling steeply with time, there are regions in the world which are rich in these fossil fuels, and there are regions in the world, a major part, which do not have any of them, and they do face problems because of lack or shortage of these sources with them. So the need for them and for others also is for to have an alternative to the fossil fuels. So what do we have for the alternatives there? The alternatives may be some kind of renewable energy sources that we can keep on replenishing, renewing. We may have the elements of natural elements of weather that may serve us for energy production. And then there is this nuclear energy production, that is the energy obtained from nuclear reactions. As things stand, somehow, for various reasons, the other alternatives, that is being solar and wind and hydro, are not giving a good enough substitution of themselves for the fossil fuels. For various reasons, they cannot, and they do not seem to, at present at least, for various reasons, be good enough substitute for these fossil fuels. Be it economy, or be it the heavy load of energy production that is required of them. So we still have in place in the country and in the world over the system of energy production and distribution, which gives heavy load on these sources and which are meant for large scale and high power to be generated and to be distributed and supplied to various users. These alternatives that are just considered presently do not have, so maybe do not have the capacity presently to fit exactly into these systems which are already in place. So maybe not only the sources themselves have to be improved for their economy, but also the distribution systems have to be renewed or changed so that good use of these alternatives that are being considered can actually become effective in place of the fossil fuels. So that leaves us with only the nuclear energy. In India, so this was what the picture looked like in the world over. India also is on the same state, is in the same state. As this slide presents, we have this ever increasing need for energy. India is a developing country, and it's one of the top two nations at least which is developing at a faster rate. So this requires more and more generation of power, and all the problems that the other parts of the world face for the energy production are true for India also. So we do also have a look at the renewable sources for the wind, for solar, etc. And newer and newer ways are being found to overcome whatever the deficiencies they have vis-a-vis the economy and economic picture and the load-bearing picture. A comparison of these different sources with the one we wish to deliberate upon for some time in the present discussion on the net here, that is the nuclear energy. It clearly shows that nuclear energy for economy, for and economy of not only money but economy of space also is having a clear upper hand over the other competitors. For about, in a rough estimate, about generation of the same quantity of power, it's very clear, as the slide mentions, the advantage that the nuclear power generation scheme has over other power generation schemes. And that's a substantial amount of advantage that the nuclear power generation scheme has over its other competitors. So, going still deeper into this, if we were to consider into the average capacity factor for this, in that also it's very clear. So, it's just not only for a reason or two, for many reasons, it seems that the nuclear energy can be the only feasible solution to today's world energy problems. So, we, if we were to pause here and see back as what actually have we been discussing till now, is that nuclear science and technology still is being put into perspective by the power usage, power generation capacity of this technology and science. And if that is so, then the questions that come to mind are, do we really require this hard look at the energy production, energy generation in our country and world over? Yes, we do, for all the reasons just we discussed. Presently, it's very clear that energy is very much required, not only to sustain ourselves at the present level, but for whatever progress we wish to maintain, we wish to make in future. We do require larger and larger amounts of energy, and for that, whatever sources which contribute presently a maximum for these energy production are not good, they need to be replaced, and the replacement seems to be pointing to the nuclear energy. So this is what it would look as the gist of the nuclear energy science and technology aspect vis-a-vis the energy production, consumption, state of our lives, etc. And if we were to zoom out a little bit, it does seem philosophically that present day and in near futures, we may have wars not just for territories and maybe less and less for the territories, but more for the control over the energy sources. I have been time and again saying that in some kind of indication clearly that nuclear science and technology is just not related to the energy aspects. So we have different uses of nuclear science and technology. So like any science, the spin-offs from this nuclear science is in wide and varied fields of technology, engineering, etc. So I am presently borrowing a few slides from the International Atomic Energy Agency's slides, which are freely available on the web. So the nuclear science and technology would and would be helping us a lot in not only energy production but in the areas of food and agriculture. So energy resources being one part, we also have to sustain the societies and to make progress, look for food security, food safety, and have some sustainable agriculture schemes. So food security obviously would suggest that we have sufficient means to provide for the food of the entire mankind. And food safety is that whatever we produce is actually safe enough for consumption and stays long for consumption. We have sustainable agriculture that whatever food we are generating for the present times and for future, which is not only sufficient in quantity, that is food security, is not only safe for consumption for present, but also for some time to keep, but also that process is safe enough to be repeated for long times to come. So with these things, we see that nuclear science and technology plays a very big part in all of these three things. That is the food security, food safety, and sustainable agriculture. So we do have for food security the crop improvement by various techniques that have come off evolved from direct use of nuclear science and technology. We have what are known as the mutation techniques. We also have what are known as the soil water crop nutrition management, wherein the best of this soil, water, and crop combination is used to generate more and more of food production. So basically, the different isotopes, radioisotopes, are used in these techniques for better management of soil and water and combination of soil water crop. We also have a significant contribution in terms of the pest control. So one part we are trying to have the food that is generated in large quantities. We are looking for species of vegetation that yield more by various mutation and other techniques which are spin-offs of nuclear science and technology. We have the use of nuclear science and technology in better managing the soil, the crop, and the combination of these three. And we also see that this nuclear science and technology is used that whatever is produced from the soil with the vegetation, that is the food, is not being spoiled by the pests. So SIT technique is used for pest control. Then what happens is that you have large number of pests. They are cultivated and produced in controlled environment. They are sterilized by using the radioisotopes, and these sterilized pests are then released into the wild, which then compete with the other wild species. And since these are sterile, they compete for mating, food, etc. And in this fashion, they try to overcome the other wild pests which consume not only the food and multiply and hence consume and spoil more of the crops, and in this fashion they control the pests. So beyond this also the nuclear science and technology uh, has helped many countries. It also helps in terms of animal production and health. We have the different radioisotopes which are used to label the reactions within the animal body cells, and then they are used as tracers and check out and select the particular species, the genes which have to be propagated further down the line. So nuclear science and technology helps in animal production and health. So this is actually a DNA assisted selection which helps in this. And we also have the radioisotopes which help in detecting the contaminants and in restricting them and from spreading further. Of course, we have the nuclear science and technology being used to irradiate food so that longevity is obtained. So so the obvious question one might have is that most of the times we try to save the animal kingdom and the vegetation from the harmful radiation, but as things are, radiation at lower levels can be used so that they do not damage the food for consumption, but they only affect adversely the other bodies which are present on them, which reduce their life. Uh, so the full radiation is very advantageously, as you might be aware, used for the longevity of the different food stocks. So these are just some of the samples of the applications of nuclear science and technology outside of the just energy production. We also are, obviously, everybody is aware of the applications of nuclear science and technology in medicine, be it brachytherapy, that is, we go to localized organs, body parts, and deliver the radiation to the cancer affected cells or tissues. We also have the techniques from the nuclear science and technology for detection of various types of ailments, cancers, etc. So, in a nutshell, we have this nuclear science and technology, which is important not only for the power generation, but it is useful to us, and we are trying to make more and more use of it to better our lives in terms of fighting diseases and in terms of producing more food stock, in maintaining that our bodies remain healthy, and so do the agriculture and the food stock also. So there are various fields with nuclear science and technology. So it is an important aspect, and the world is coming to more and more to the advantageous uses of this science and technology for mankind. So with this in mind, that is, the country requires more and more of manpower to deal with, to understand, and to work in areas of nuclear science and technology. The University of Petroleum and Energy Studies began with a nuclear science and technology program, an M.Tech program, a 2-year M.Tech program at its campus in Dehradun in 2013. So it's a 2-year program, and it's aimed at providing students with in-depth understanding of not only, as the name suggests, the science aspect of the nuclear energy and its applications, but also the engineering and technological aspects of this area. So this department began in 2013, as I mentioned. It has a M.Tech program, 2-year M.Tech program, and it deals with both the science and technological aspects of this area. So if we were just to observe at what are the different courses that are delivered in this program, it's very clear. So we have 3 semesters out of 4 in this program, which are aimed at giving the theory and lab courses to the students. And in the 4th semester, one entire 6 months of time is kept for project work. A look at the different courses that are delivered. As I mentioned just a while back, we not only have the science but the technological aspects also. So, being a nuclear science and technology, we necessarily have to have, anybody has to have nuclear physics to be delivered in the program so that one understands actually the core. And to understand the core, comprehend it, we have the course on quantum mechanics and electrodynamics, which forms the backbone of the entire subject of nuclear physics. So, without understanding the quantum physics, the quantum mechanics, it's not possible to actually comprehend clearly the aspects of nuclear physics and hence the application part of it in terms of nuclear energy and nuclear engineering and nuclear technology. We deal with the different radiation sources, what are the sources for nuclear in the nuclear field, what are the ways they can be studied, how are the sources being so if there are sources, what way do we say detect them, what are the measurables in that, so that then we understand that there should be a good backing of mathematical techniques to solve some of the problems that we will be using to understand the application part of nuclear science and technology. We do have, so more and more now, in fact, engineering and technology cannot be existing without computations. So we do have the students to learn computer programming and simulations, and that course has been adapted to suit for whatever comes later on in this program of M.Tech Nuclear Science and Technology. We go deeper into the second semester and deal with the nuclear reactor physics and nuclear reactor theory. So, uh, as you might be aware, all of the reactors, the energy producing reactors in the world, deal with fission technology. So, when one talks about nuclear energy, there are two processes that yield energy. One is nuclear fission, and the other is nuclear fusion. Fission, as the name literally means, is the breaking up of heavier nuclei into two smaller nucleus into two smaller nuclei, and the other is fusion, as literally suggests, the coming together or fusion of two lighter nuclei into one bigger nucleus. So, as I was mentioning here, all the nuclear energy that is being generated the world over deals with nuclear fission process. So all the reactors the world over, they use nuclear fission to produce energy. But there is this ambitious program, the leaders in nuclear energy that are working on by the name of ITER, International Thermonuclear Reaction Program, and that is so. Though the first acquaintance of the mankind with the nuclear energy should have been from the fusion process, that is the sun, the sunlight we see, and that is the source of all energy for everything that is not only on earth, for all the planets in the solar system, comes from the fusion process. So, but all the energy that is produced in the reactors the world over, they come from fission process. The scientists, as I mentioned, the world over, the leading nations, a conglomeration about presently 7 nations have decided to come together to produce energy from nuclear fusion process, and that would be much more cleaner. Already the nuclear energy is cleaner than all other energies, conventional energy sources that we have, but what the nuclear fusion would yield would be still more cleaner and much more economical. So for aspects dealing with that, we have the plasma physics and nuclear fusion reactor also incorporated as a course into this program. We have a course on the understanding of the nuclear engineering materials that deal with the different aspects of nuclear science and technology. We have the within the reactors and the understanding of fluid dynamics and heat transfer. So as the reactors, they are So the nuclear reactors, as some of you may be knowing, that are similar to the other reactors, only that they use nuclear sources for heat generation, and later on, like any other source of heat generation in any other reactor, this heat is then used to convert water into steam, and that steam then runs turbines, and that's how the power is generated. So it's the first part of the reactor that is using the nuclear process. So we do require the understanding of the fluid dynamics and heat transfers for the engineers who study nuclear science and technology. We then have an application part that is, as I mentioned, there are so much advantageous applications, not only in terms of the energy generation, but also in terms of nuclear medicine and also for in the industry. So there are what are known as the non-destructive techniques that use the nuclear science and technology for determination of the strength of materials, etc., uh, in ways in which the other conventional techniques cannot be used. We have a nuclear measurements lab wherein all the basic understanding that has been obtained in terms of the nuclear radiation, the detection, their measurement is actually understood practically in the laboratory environment. We do go still deeper into the reactor aspect. We teach a particular type of reactor, fast breeder reactor, which we have at IGCAR, Indira Gandhi Center for Atomic Research at Kalpakkam, that is fast breeder reactor. We then have an understanding of radiation shielding, dosimetry, etc., to be understood by the students. We have a hardcore, very difficult to understand, as these students all over the past batches have been mentioning about the neutron transport theory. We then go into the nuclear power engineering aspects also with another nuclear measurement lab associated with all of these courses being conducted. So so this is what the scheme of the course is that is being presented at the University of Petroleum and Energy Studies, and we have one full semester for the project work. So if this is so, do you really have the next question would be that what are actually the advantages that this program would have over its other competitors? Now, firstly, because of the nature of the program, not many universities and organizations have this masters in nuclear science and technology running on their campus. Just a few handful of you have these programs running, and still a couple of more or some more had been, but because of the difficulties associated, they have been shut down. So we've been we are happy we've been running this successfully, and as our student feedback tells us, we've been doing pretty good job of this. We came much later than many of them, but we have survived many of them, and we are still going strong. So we have this M.Tech 2-year program. So what do we have? So already, as I mentioned, there are only few centers, universities and organization, prestigious ones, which offer that, and we have this. And in our program, we offer some things which are not offered by our competitors. The course structure, to begin with, the course structure itself is much more um, holistic in nature, that it encompasses almost all of the things that are required to be understood in nuclear science and technology. So we have aspects on science and technology. We have in that related to nuclear reactor designs. We have reactor operations. We have those courses dealing with waste management, radiological applications, and the very foundation of them, nuclear science also. So this itself is being conveyed here is different from mm, the way also is different from how our competitors are presenting to the student world. So it is not only in terms of the course structure that we believe we stand in an advantageous position. There are other aspects in how this is being delivered is also we believe we are doing very well. Our in-house faculty in which deal with the M.Tech nuclear science and technology, they have had experience at the various department of atomic energy units in the country. I myself have been associated with Institute for Plasma Research at Gandhinagar, which has this international program ITER I mentioned a while back. I have been there. I have been at the Tata Institute of Fundamental Research, Mumbai. I have my colleague, Professor Shivramu, a distinguished professor who's been at IGCAR for 40 years plus, and we have this immense knowledge bank carried by him from there. We also have other faculties from other departments who have from physics, from chemical, who have had their stints from electrical engineering as well, from varied departments, who have had experience of working at different Department of Atomic Energy units in the country like IGCAR and IPR, but some of them have been at outside places also. So we have an in-house faculty which has been at, as mentioned, at the core of some of the prestigious institutions in the world. We have had a galaxy of visiting guest faculty from a few names to mention here on the slides, like Professor V.K. Gupta, distinguished professor from the Delhi University. We had Professor Claude Guet, presently from Singapore's Nanyang Technical University, and he has been, I beg your pardon, former deputy head of the Atomic Energy of Commission of France, CEA France. We have Professor C.V.S. Rao, who's a professor at the Homi Bhabha National Institute and also a scientist consultant at the Institute for Plasma Research. We have Professor Gorachan Chakravarti, distinguished scientist, retired from Bhabha Atomic Research Center, BRC Mumbai. Professor Paranjape, distinguished scientist again from BRC. He had been heading an entire school of nuclear science and technology at one of the uh, prestigious private universities in the country. We also have Professor Abdesalam Abdelou from France, École des Mines de Nantes. He's our collaborator and head of the Subatec experimental facility there. We have Professor R.K. Shivpuri, who presently is at the Modi University, a very distinguished scientist, academician of our country. He's had the highest civilian award from France. He has that to his name. He has his name for some very big discoveries at CERN, like the quark discovery and the discovery of God particle. We also have Professor Vinod Kumar, ex-BARC from Mumbai. So not only the in-house faculty has been at the various DA units, we have had a galaxy of visiting guest faculty coming to teach various other courses to our students for this program. We have a 1 year, so as I mentioned, we have this course structure which we believe and we are sure is in an advantageous position vis-a-vis our competitors. We also have top bracket in-house faculty, a galaxy of visiting guest faculty, and we have an international collaboration wherein our students, after their first year of studies at the campus in Dehradun, have the option of pursuing their second year at École des Mines de Nantes in France. So they may go for their entire year, 1 year exchange program to study there. They may, and so they study for therein, as the structure stands, they study for the third semester, wherein the theoretical courses and lab courses are delivered just like they are here. And in the last semester, fourth semester, like here, they do the major project work at industry. So till now, they have been doing it at various prestigious organizations in France. Till date, whatever students we from our program have reached there have been successfully going into those major projects wherein they work at some of the prestigious institutions, organizations in France, and they do get, by the way, paid well in terms of their internship money. Besides this, inside here also our industrial visits and internships for the students are held at DA units like the Indira Gandhi Center for Atomic Research, Kalpakam, Tamil Nadu, and Institute for Plasma Research at Gandhinagar. So the industrial visits, wherein like any M.Tech course, the class goes and visits the various labs at these places, and they firsthand get to see the things they study in the classes here. The summer internships also till date have been performed at IGCAR, wherein they have been lucky enough sometimes, most of the times, I beg your pardon, to go and see into the reactor facilities. And lucky in the sense that normally the reactors in working conditions are shut off for the outsiders and the visitors, etc. But the time they have been visiting there for the maintenance work, etc., they have been open for last 3 or 4 times. Our students have been visiting, and they got first-hand experience of entering into those facilities. So for a student in this course, we have the regular courses in theory and labs. We have the industrial visits to make. There are the summer internships to be done between in the summers of the first year and second year. And they also have these major projects. We have, by design, insisted on our students performing these major projects at the DA units. So we, the faculties here on campus, in collaboration with the faculties there, have our students working and have first-hand experience for about 6 months to work on the ongoing projects at these research facilities. So that is an absolutely quote unquote in terms of the words of the students an awesome things in the parlance of the students of the present generation experience for them. So all the aspects, that is, we have the courses, the course structure, the faculties inside, the faculties from outside, the summer internships, the industrial visits, and the major projects that are being uh, performed are dealt at the DA units and the personnel related to them. So this is what. So if one were to give the, in nutshell, the entire thing, the key features and benefits that this program of M.Tech Nuclear Science and Technology holds for the students would be as presented on the slide here. So if you would just uh, permit me, just for this case, to read out each one of the salient features here is that in-depth knowledge, and as I mentioned, the structure of the course itself. We have the personality development programs, the communication classes, the industry tour, etc., to the DAE, Government of India units. We have the memorandum of understanding with equal the mean, the noun, for which 1 full year of exchange program exists for our students. The summer internships at DAE units, the in-house faculty with work experience at DAE, the very eminent scientists engaged as visiting as guest faculties. We also had, which I couldn't put before this, and I'm happy to mention here when I'm going through the gist of whatever the features are associated with the program, that the guest lectures also on and off have been held from prominent professionals in the field. PhD opportunities from the premier research laboratories in the country exist, and our students have been going to them. The career prospects then are that they have chance to work at the labs in the UAE, the organizations dealing with these, the industries dealing with the nuclear science and technology, They also have the option, the chance of with the radiation safety and environmental measurement management, beg your pardon, the aspects, the job areas related to the medical applications of the science and technology, and so also at a later stage for the consultancy. So if this is so, do we actually have any hard examples to present if the whatever options that I mentioned do actually exist for our students? Yes, they do. Our students from the first batch, as I mentioned, was from 2013 to 15. So the people who passed out from 15 have entered into PhD programs at the top-notch institutions in the country and outside. So we have our students at Institute for Plasma Research, IPR Gandhinagar. We have students at Indira Gandhi Center for Atomic Research, Kalpakkam, Tamil Nadu. We have students at IIT Kanpur. We have students at Atomic Energy Commission France. We have student in IRSN, a similar body in France. So we do actually have uh, not only these options, but they have been availed of by the students that have passed out from our program. So with this, I would like to stop here. I hope I have conveyed. Beg your pardon if I overshot whatever time I was supposed to speak to you, interact with you. So, I hope I have been able to convey the nuclear energy scenario in brief for the world, for our country, and the aspects that deal with the M.Tech Nuclear Science and Technology program that we have at our campus at University of Petroleum and Energy Studies there. Thank you very much, and I would be happy to deal with whatever queries or questions that you may have. So, I do have I have been getting this question from TSK Craft. I'm sorry, I believed, I thought I would present the thing initially, and then I would have the questions because of the screen here. So I understand there is this query about whether the nuclear engineer is good for us, for Earth or not. Yes, nuclear energy is very good for us, for Indians, and for whole of the Earth. The fears that linger in our minds, uh, those are actually misapprehensions. And we have scientists from uh, the institutions, organizations, not only in the country, but outside also, and so as I, actually informing the people that these are misapprehensions. The threat or the we see from nuclear establishments are much less in number as compared to from some other sources. So yes, answering to you, TSK craft, the nuclear engineer is really good for us and good for Earth. We do have so and the waste maybe if that is being so there are two aspects. One understands the fears in the mind of the people. There are two things in which these lay. One is regarding the safety and security of these establishments, and the second is regarding the nuclear waste. So in both of these aspects, uh, so so as I was mentioning, in both these aspects we do have. So we have a query who keeps security, what scientists are doing. So scientists are responsible a lot. They are not standalone. They have their in a way supervisors who look after what they are doing, and all of these activities are monitored at the top level. We also obviously have the International Atomic Energy Agency, which looks up um, after whether whatever the regulations are in place are adhered to by the member nations and others also. So, how India works on it for real? Well, it is as real as it can be. We have absolutely uh, zero tolerance for anything. In fact, we are a shining example for non-proliferation. While some of the nations, um, whether they deny or not, it's an understanding, international understanding that they have not been clean with that. Our programs have been closed with respect to the agencies that are in place. The regulations have been forward, have been adhered to, and so there is a further question: if is it the cost money for the country to get money? So initially, till now, it was the fuel, it was the source to run these reactors that we did not have. So as you would be aware, we do not have sufficient deposits to run our reactors. But now, since the last year, we are getting into agreements with a number of countries for civilian use of nuclear energy, and so we are hopeful that soon we will have sufficient quantity of the fuel to run the reactors and to get some more running. The So this is why we have not been able to, and it is for this actually, since we do not have sufficient quantity of that, we've been trying to develop another technology different from what the other countries in the world have been doing. So we've been trying to use and develop that, but still it is some time away, and we are happy that we are getting into the agreements with many countries like Canada, Australia, the USA to get the sufficient supplies to get our reactors. So I have another query from the same. Do you support everyone to search on nuclear energy engineering, uh, or just scientists? Well, I do not understand for completely for search on nuclear engineering. The nuclear engineering courses are there. It's open to everybody who qualifies to join them. It's open here at the UPES. It's so open at other private universities also. We also have the DA units, BARC, which are taking the aspirants from the general society for the training schools at IPR, for at BARC, at IGCAR. Yes, it is open to the general public. So it requires some rigor and understanding of the subject. But if we have that, it is open for us to join those fields. Well, thank you for asking those questions. 17 years of age. Yes, yes. I congratulate you for your maturity. Uh, Nice to have. Thanks those questions, but good questions those. So yeah, congratulations. You are very much welcome to approach any one of us for any knowledge that you wish to have. The program that we have is M.Tech, that is the master's program. So I believe you would be entering into your bachelor's program presently sometime soon, and after that, if you are interested, you are very much welcome to the nuclear fold. So I welcome if anybody has any further questions on the interaction we've had, the seminar on the web or the webinar as it's called. Yes, TSK Craft is asking if the programming that I mentioned is programming computer codes. Yes, it's very much programming computer codes. So scientists world over have been dealing in Fortran, Progress to C, C++. So we do have faculty teaching these courses. We start with these courses, and yeah, it is the same that you've been asking. So, any further questions from the audience out there? Yes, of course, TSK Craft, the students do have computers and tools in this university to search and learn. As I mentioned, we have so many courses which are delivered by so many people, and we have this different organizations in the country which actually are doing research in this area. So the students do get to work in those areas for their projects. As I mentioned, we insist for the students to go there and do their projects and learn on some of the ongoing projects of the top-notch organizations. And we said they do nuclear engineering for real or in old age. Uh, they are doing for the real and for present. So in the present areas, if they are not developing any new nuclear bombs or anything, we in the civilian programs we are dealing with the development of materials to be used for nuclear science and technology. We are working for the development of technologies for fusion program. We are developing technologies to better for the fission programs. We are developing science and technology and their applications in medicines, in detection, in food management, etc. So yes, they are all very much for real. And in the present age, so the institutions exchange and civilian workshops, seminars, etc. Their works they do, the findings they have, they make world over. So this is for very much for real and at an old age. Can they solve for climate change and natural problems? Yes, if they take the nuclear way, then they are solving for the climate problems. That's what is being impressed upon in this and program, webinar, and so by the other scientists world over that our climate problem can be solved if we change to the nuclear energy. That's what the thrust is. That's what the basic understanding is, and yeah, again, the other part of the question is why countries not cooperate on things like nuclear engineering. Well, the countries are cooperating. We have the International Atomic Energy Agency, which is looking after um, the countries in the world, the civilian programs. What they are not cooperating is only in the area of arms, which anyway, non-nuclear arms also, the countries do not cooperate. They sell or buy these things. So that's what some do cooperate in setting up the I beg your pardon joint technologies etc. But those are very few and far between. So countries are cooperating. They are working together in civilian areas, and whatever they are not are in the regimes of the arms etc. So any more questions from anybody there? Okay, thank you very much for your presence during the webinar. Uh, well, there have been we in classes we have the students, so we are looking forward to these courses, and so also in the lab. Okay, thank you once again for your kindness to be present here for the webinar. Have a nice day. Thank you.